This style of question is a very common question at both GCSE and A-Level. You can see there is a combined worth of 6 marks for this question, and they've conveniently split them into 4 separate questions. Be prepared to do all of these steps in one single question, which has come up in previous years. Let's get in. First thing first, you must analyze the question. 20 centimeters cubed of sodium hydroxide, which has an unknown concentration, is placed in a flask. It is reacted with 25.10 centimeters cubed of hydrochloric acid, which has a concentration of 0.128 moles per dm cubed. It's a neutralization reaction, which means we form a salt and some side products. All answers must be given to 3 significant figures. And the first part is to calculate the amount in moles of hydrochloric acid with this volume and this concentration. So let's get stuck in. Volume is equal to 25.10 centimeters cubed, which we need to convert to decimeters cubed. The concentration is 0.128 moles per dm cubed. And the question wants us to work out moles. The formula being N equals C times by V. Plug in the numbers. And you should work out an answer of 0.00321 moles. That's worth 2 marks. Second question, write an equation for the neutralization reaction between hydrochloric acid and sodium hydroxide. So we start with hydrochloric acid, NaOH, which forms sodium chloride and water. You've got to make sure the equation is balanced, which, if you check it out, is fully balanced. That's 1 mark. Part D. Use your answers to parts B and C to determine the amount of NaOH, amount being moles, in 20 centimeters cubed of sodium hydroxide. Now, we've already worked out the moles in part B. And in my opinion, the best way to tackle this kind of question is to use stoichiometry. It's not the only way, but it is a very useful way. So let's get stuck in. Information we have. We know the number of moles of our acid, which is 0.00321. The ratio, the molar ratio, is 1 to 1. Notice we don't actually care about sodium chloride or water for this question, so we can ignore them. With a 1 to 1 ratio, that would mean that NaOH, we also have 0.0321 moles of NaOH reacting with 0.00321 moles of hydrochloric acid. They have given us a volume and if you look at the next question, part E, we need to calculate the concentration of the sodium hydroxide in the conical flask. So plug in the values. We have a volume of 20 centimeters cubed, which is equivalent to 0.020 dm cubed. And to work out the concentration, all we need to do is plug in values into our formula, which is C equals N divided by V. The moles are 0.00321, and we need to divide that by 0.020. Oh, is that the camera? And that gives us a value of 0.161 moles per dm cubed. So that is how we can use a known concentration and known volume to work out an unknown concentration via titrations.